Lesson 6.9, Systems of Inequalities. So now we're just combining our system of equations but using inequalities. So you're going to multiple inequalities. We're trying to figure out first which point would be a solution to the system. That means that I have to plug these points in and it has to work for both of these inequalities, not just one. So remember our ordered pairs go x comma y. Y is 2. Is 2 less than 2 times negative 4 plus 2. Well, what is this? 2 times negative 4 is negative 8. Negative 8 plus 2 is negative 6. Is 2 less than negative 6? No. So I don't even have to test the other one. That one's out. Let's try the second one. Y is negative 8. Is negative 8 less than 2 times our 4 plus 2? 2 times 4 is 8, plus 2 is 10. Yes, that does work on that one. Let's try it on this one. Is negative 8 greater than or equal to negative 3/4 of 4 plus 3? And so I'm hoping you could do this in your head. Of 3/4 of 4, if I wanted 1/4 of 4, that would be 1. 3 of those 1s would be 3. What's happening here is this 4 is over 1, so these 4s are cross-canceling to give me negative 3 over 1. So negative 3 plus 3. That is 0. Is negative 8 greater than or equal to 0? No, it's smaller, so that one's out. I'm running out of room. Okay, let's try the next one. Negative 1 is my y. Is negative 1 less than 2 times negative 8 plus 2? That would be negative 16 plus 2 would be negative 14. Negative 1 is definitely not smaller than that, so that one should be out. Hopefully I'm doing it right. Didn't make a stupid mistake. So y is negative 2. I'm going to have to do it over here. Is that less than 2 times 8 plus 2? 16, 17, 18. That would be negative 2 is less than 18. Yes. So that one works. This one is negative 2 greater than or equal to negative 3/4 of 8 plus 3. So think of now your 8 and your 4 can simplify. Divide by 4. That becomes a 2. Negative 3 times 2 is negative 6 plus 3. Is negative 2 bigger than negative 3? Yes, it actually is, because the closer you get to the 0, that means it's bigger than negative 3. So that one is our answer. Of course, I made it the last one. All right, and then number 2, we're going to just do one example. Hopefully that's enough to get you going. We're going to graph a system of inequalities. And so the good thing is they're already in y equals mx plus b form. So on this first one, I would start up at 7. My slope is 1, so I'm going to go up and right. Okay, I need to look at my symbol. It's greater than. It's not equal to, so I'm going to have to make a dashed line to show that these points are not actually solutions. They just create a boundary line. Okay, so greater than. That would be shading above the line, which would be this direction. And so then when you're on Delta Math, you'll have to click a button that says you want to change the shading, and you have to just keep pushing that button until it shades the region you want. All right, and then the second one, I'll change colors. We'll start at negative 5, then go down to right 1, up to left 1. I like to see where they cross, even though it doesn't really matter. Okay, and then my symbol does say it can equal at those points, so I make a solid line. And then ignore the purple, I'm doing less than. So that'll be below the line. So if this is my line, picture it being top heavy and falling, below would be down here. So we want the section that has shading in both areas, which would be all of this. So any points that lie in just this little region right here would be solutions, and the ones that are on the solid, but not the ones that are on the dashed purple line.